video A15. And we're just continuing with section 7.5 where we're learning to solve logarithmic and exponential functions. I guess I'll call this one 3 since it's a continuation. So let's try to solve another equation. This time we're dealing with a logarithmic one. And a lot of students worry that we have a negative over here, but remember, you can't have a negative as the base or as this argument inside the log. But it's okay over here because watch what happens. Remember, logs and exponentials are inverses, and so I'm going to convert this to exponential form. And what that will do, it will get the x outside of this logarithm. So I can solve for the x. And so I get 6 to the negative first equals 2x minus 1. And kind of a simple equation now. Okay, and so this is 1/6. And I know I'm about to add this to the side, so I'm going to change 1 to 6 over 6. So I'll add 6 over 6, and I get 7 over 6 equals 2x. I divide by 2, which is going to double this denominator. And I get x equals 7/12. We probably should go and check to make sure that this does make sense. Okay, it's always a good idea to check our solutions when we're dealing with kind of unfamiliar equations. And so let's see what happens. Log base 6, 2 times this will be 7 over 6 minus 6 over 6. Okay, and so I'm hoping that it equals -1, but let's go ahead and see what it does equal. So here I have 1 over 6. Okay, and maybe if you don't see it yet, isn't 1 over 6 the same thing as 6 to the negative first? Can't we pull that out in front as the coefficient? And log base 6 of 6, I hope you know, is 1. So I get -1, like I was hoping. Okay, problem 4. Log base 4 of 100 equals log base 4 of x plus 1, and outside plus 1. Okay, so now I have 2 logarithms. What I want to do is use my log properties and combine them. To do that, though, I need them both on the same side. Okay, and this isn't the only method we could use here, but let's go ahead and subtract this from both sides. And then I have 2 logs with the same base. They're subtracted, so I can write that as a single logarithm. That's the positive one, so it goes on top. That's subtracted, so it goes on the bottom. So you can see we're using those log properties now. Okay, and then we're to a point here where I want to change to exponential form so I can get the x outside of the log, make it solvable. So we get 4 to the first, which is just 4. And then I would maybe cross multiply. Just half works. You could put a 1 here and do the whole thing, but I can't forget to distribute here. I get 4x plus 4 equals 100. And I'll subtract the 4 and divide. And once again, I shouldn't really trust that that's the answer. So let's go ahead and see if it is. So if I go ahead and try to put the 24 here, let's see what I get. So I'm going to do it this way this time. So this is my check. So on this side I have log base 4 of 100. On this side I have log base 4 of 25. And I want to write this one as a log base 4. Isn't that log base 4 of 4? And then I can write this side as a single, and I should put a question mark above the equal sign. Okay, and I can write this as a single log. They're added, so I multiply them, and 25 times 4 is 100. And so it did check out. Let's try another one. So here, there are a couple ways we could do this. I'll show you both. Actually, there are probably many ways to do it, but the simplest way for this. Okay, the difficult way, the gut instinct is to say 5 to the 8th equals x to the 4th. And we'll do that in a second here. But I think an easier thing to do is bring out your exponent as a coefficient. Divide both sides by 4 and change to exponential form. And so I get 5 squared equals x, so x is 25. Very quick answer that way. Perhaps a more difficult way, and I'll probably, on your homework, I'll probably go back and forth between these two methods. Maybe sometimes I'll show both. We'll just see. Okay, so let's see a different one. The first instinct was to immediately change to exponential form, and I get 5 to the 8th equals x to the 4th. And then I have to solve for x, so I have to take the 4th root of both sides. And I know taking the 4th root is the same thing as raising it to the 1/4 power. And then, let's see what I get. I have an exponent to an exponent, so I multiply 8 times 1/4, which is 8/4. And I do get what I was looking for. So you choose your method. I prefer the first. Let's try one more problem here, and I'll give you your homework. This is problem 6. Okay, so you go ahead and pause the video. You try it, and come back and you can watch my solution. All right, so what we did in the last one is we wrote these as one logarithm by multiplying. And when I multiply, I'm going to distribute. And now I'll go ahead and circle the base, go across and come back. And I get a quadratic. Okay, I'll get everything on one side. It looks factorable. Hopefully we remember how to factor. So I'm going to do 4 times 3 is 12. Make that positive, make that negative, and I would get the positive 1x in the middle. And so my solutions are that. But don't forget, every time we've been doing this, we've been checking. And immediately I see if I try to put a -4 in here or here, I have a negative inside a logarithm. So the only one I'm going to check is this. So 3 plus 1 is 4. Okay, I'm hoping that this will equal 1 in the end. I'm going to multiply these together inside one logarithm, and I get log base 12 of 12, which is 1. Okay, your homework are these 3 problems, and you do your best. Go ahead and pause the video. I'm about to show you these solutions.